NASA's press conference on November 19, 2025, became a major point of attention for astronomers, science fans, and the general public, especially because rumors and sensational claims had been spreading non-stop across social media in the weeks leading up to it. Many people online had begun associating Comet 3 I/Atlas with extraterrestrial life, mysterious signals, and exaggerated doomsday narratives. To address this wave of misinformation head-on, Associate Administrator Amit Kshatriya opened the event by making a clear, calm, and direct statement. He emphasized that this object is a comet, an icy visitor from beyond our solar system, and absolutely nothing related to alien spacecraft, intelligence, or biological life. His reassurance helped shift the mood from speculation to scientific curiosity, setting the stage for the remarkable images and data NASA was about to release. During the conference, NASA showcased the efforts of multiple spacecraft and telescopes across the solar system, all of which had been directed toward capturing views of Comet 3 I/Atlas, the third confirmed interstellar object to ever pass through our cosmic neighborhood. Each mission offered a unique perspective, creating a mosaic of observations that revealed the comet's evolving appearance as it journeyed around our sun. Among all the missions involved, the Mars Reconnaissance Orbiter, MRO, happened to get the closest and clearest view. On October 2, 2025, when the comet was approximately 19 million miles from the red planet, the orbiter successfully captured a detailed image that stunned scientists. Even from that distance, the comet's developing coma and early signs of jet activity were visible, confirming that sunlight was beginning to heat its surface as expected. But NASA wasn't the only source of insight. Throughout this period, a trio of highly respected astrophotographers, Michael Yeager, Gerald Riemann, and Enrico Prosperi, were also diligently tracking Comet 3 I/Atlas from Earth. These astrophotographers are known for their exceptional comet imaging skills, often producing photographs that rival professional observatory quality results. As the comet completed its closest approach to the Sun on October 29, 2025, its behavior changed dramatically. After rounding the Sun, the comet re-emerged in the eastern pre-dawn sky, becoming visible to experienced telescope users who knew exactly where to look. Yeager, Riemann, and Prosperi captured some of the earliest and most detailed ground-based images of the comet during this phase and generously shared their work on the ICQ Comet Observations page on Facebook. Their photos quickly circulated among astronomy enthusiasts worldwide, bringing the excitement of this rare interstellar visitor directly to the public. One of their most striking images revealed that Comet 3 I/Atlas had been significantly altered by its close passage near the Sun. This behavior was expected, as comets, especially those visiting for the first time in billions of years, tend to react dramatically to strong sunlight. The intense heat causes their icy surfaces to crack, vaporize, and expel dust and gas. In the case of 3 I/Atlas, the images showed multiple bright jets erupting outward in various directions. These jets formed as pressurized gases burst through the comet's surface, carrying dust particles into space and creating the long, wispy structures that give comets their iconic appearance. Astronomers were thrilled to see this activity because it provided clues about the comet's composition and the conditions it experienced while traveling between star systems. As NASA explained during the conference, Comet 3 I/Atlas reached its perihelion, its closest point to the Sun, at 11:47 Universal Time, coordinated on October 29, 2025. At that moment, the comet was roughly 1.36 astronomical units from the Sun, equivalent to about 126 million miles, or 203 million kilometers. Although this distance may seem large by everyday standards, it is well within the range where solar radiation becomes powerful enough to dramatically alter a comet structure. Scientists suspect that the comet originated from a distant star system, possibly one with an Oort cloud-like region similar to our own. The fact that it has survived its journey across interstellar space and into our solar system makes its behavior especially valuable for researchers seeking to understand how planetary systems form and evolve. Even though the comet is now on its outbound path and slowly making its way back into interstellar space, its story within our solar system is not quite over. While 3I/Atlas has already passed the Sun, it has not yet reached its closest point to Earth. That milestone is expected to occur around December 19, 2025, when it will pass at a distance of approximately 1.8 astronomical units, about 168 million miles or 270 million kilometers, from our planet. This distance is far too great for the comet to appear bright to the naked eye, so casual skywatchers will not be able to spot it without assistance. Still, for those with access to telescopes or astronomy clubs, the comet presents an exciting target. The idea of observing an object that formed around another star system is thrilling even for seasoned astronomers, and telescope owners around the world are preparing for their chance to glimpse this rare traveler before it disappears beyond our observational reach. NASA scientists emphasize that despite the comet's faintness, it remains scientifically rich. Even a faint interstellar comet can offer tremendous insight into cosmic chemistry and the raw materials found in other regions of the galaxy. Every image taken by spacecraft or telescopes contributes to a deeper understanding of how 3I/Atlas interacts with sunlight, space dust, and gravity. These observations also serve as valuable comparison points when studying the two previous interstellar objects, 1I/Oumuamua, which passed through our solar system in 2017, and 2I/Borisov, discovered in 2019. Each of these objects behaved differently, hinting that interstellar comets and asteroids can vary widely depending on the environments in which they formed. 3I/Atlas now joins this small but immensely important group of cosmic visitors, and scientists are eager to study how its structure, orbit, and composition differ from its predecessors. In the weeks following its perihelion, astronomers monitored how the comet's jets expanded and how its dust tail stretched across space. Because the comet is moving at extraordinary speed, far faster than typical long-period comets native to our solar system, its dust and gas trail behaves differently. Patterns in the tail can reveal the direction of the solar wind at various points in the comet's journey, offering additional data for heliophysics research. Every detail captured, whether from orbiting spacecraft or ground-based observatories, becomes part of a larger scientific puzzle. By studying these patterns, researchers can learn not only about the comet itself, but also about the physical conditions of the space it is traveling through. As 3I/Atlas continues its exit from the solar system, scientists around the world remain dedicated to gathering as much information as possible before it slips beyond the reach of our instruments. The comet is expected to fade gradually over the coming months, becoming dimmer and more difficult to observe. This slow disappearance adds an emotional layer to the event. For a brief period in 2025, humanity was able to witness and study a piece of another star system, a fragment of cosmic material that spent millions of years traveling through the galaxy before crossing paths with our own solar system. These moments provide a humbling reminder of the vastness of space and the rarity of such encounters. NASA's collaborative approach, involving multiple missions and partnerships with the global astronomy community, reflects the shared excitement and curiosity that interstellar objects inspire. Although 3I/Atlas will never shine brightly enough to capture the attention of the general public, its scientific value is immense. It serves as a messenger from a distant region of the universe, carrying secrets about the dust, ice, and chemical ingredients that shaped planets around another star. By studying it in detail, scientists hope to unravel more about how solar systems like ours begin, evolve, and interact with their cosmic environments. And for those who enjoy stargazing, the knowledge that an interstellar visitor is currently passing through the night sky, even if only visible through telescopes, adds a sense of wonder to every clear pre-dawn morning. Far from being a threat or an alien mystery, Comet 3I/Atlas stands as a symbol of exploration, discovery, and the awe-inspiring scale of the universe.